Well, let's continue the worksheet for this topic 3, elemental composition of pure substances. Still about the molecular and empirical formula. Even though the atom is the smallest representative sample of an element, only the noble gases elements are normally found in nature as isolated atoms. Monoatomic, I mean. Several elements are found in nature in molecular form. This is known as two together. So two atoms together or more. If it is two atoms from the same type, it will be called diatomic. While molecular formula describes the actual number of atoms, but they can often be, while molecular formulae describes the actual number of atoms, but they can be often simplified. But they can be often simplified to their smallest ratio, which is called the empirical formula. So molecular formula is H₂O. Its empirical formula is still H₂O because the ratio is 2:1. We can also find something called the mass ratio. We find this by multiplying each number of moles by its mass. So this mass of hydrogen is 1, mass of oxygen is 8. How come the mass ratio is 1:8? I will tell you how comes the mass ratio is 1:8. Because every 1 atom of hydrogen comes with 8 grams of the oxygen. How did you get that? Because I know that 2 hydrogen atoms comes with 16 grams, so 1 will come with 8 grams. So this one should be in grams. The H₂O₂ shows HO as a ratio. Empirical formula is 1:1. Again, the mass is 1:16 this time, not 1:8, because the ratio is 1:1. C2H6O2 is CH₃O. So the ratio is 1 to 3 hydrogens to 1 oxygen. The mass of this one is 12. The mass of this one is 3. Why? Because 3 hydrogen atoms multiplied by 1, and this is 16. This one, the empirical is CH. The ratio is 1:1, so the mass ratio is 12:1. So the mass ratio is actually only the ratio, but written in grams instead of number of moles. So what is the difference between molecular and empirical formula? The molecular formula shows the actual number of atoms. The empirical formula shows the simplest whole ratio. Example C6H6, the answer is CH as the empirical. And what is the empirical formula of C4H8? The ratio is 4:8. So simplify by dividing both of them by 4, you will get the ratio as 1:2. The correct answer is CH2 as your empirical formula. So let's summarize what we did now in this table. The table helps us find the empirical formula of the compound by comparing the molecular formula, the actual number of atoms in the molecule, to the empirical formula, the simplest whole ratio for the atoms. The mole ratio is the number of each atom type compared directly. So I have hydrogen here 1 and oxygen here 1. So this will be 2 and 1. This is in the H₂O, but in the H₂O, the ratio is 1:1. So the number of atoms ratio. And the mass ratio is total mass of each atom type compared. So what is the mass of this one to the mass of this one? How to find the mass ratio? Multiply the number of atoms by the atomic mass, then simplify it. For example, H₂O, multiply here, this ratio is 2:1. So multiply 2 by 1, it is 2, and O is 16. So it is 16, 2 to 16, so simplified will be 1:8, and it will be in grams for sure. Now let's see how we can find the empirical formula for a certain compound. This compound, we don't know its structure exactly. We know that it only contains 12 grams of carbon and 2 grams of hydrogen. So what is the empirical formula? This is the compound. It is made of these 2 parts, carbon and hydrogen. So let's try to first convert the mass to moles. But why you are converting the mass to moles? We are converting the mass to moles because we need to know the ratio of the number of atoms of this carbon to the ratio of the number of atoms of the hydrogen, the simplest ratio. And we cannot count atoms as we agreed. So we have to change it into moles. We agreed that counting moles is not easy. Counting atoms is not easy. Counting moles is easier. So we need to change these masses into moles. We do this by dividing the mass by the molar mass for every one of them. So the first step converts the masses to moles. The 12 grams of the carbon will be divided by the 12 grams per mole, which is its molar mass. We get 1 mole. And this hydrogen, the 2 grams of the hydrogen divided by 1 gram per mole, which is its molar mass, we get 2 moles. So the ratio tells us that for every mole of atoms of carbon, we have 2 moles of hydrogen. Now let's try to find the simplest ratio. Yeah, it is 1 to 2. Here it is 1 to 2. And we do this for more difficult ones by dividing by the smallest number. If the number is bigger, like I have 2 to 4 instead of 1 to 2, so I'll divide both of them by 2, so the ratio will become 1 to 2. This means that for every 1 carbon atom, there are 2 hydrogen atoms. For every 1 carbon mole, there is 2 hydrogen moles. This is the simplest whole number ratio. The empirical is what? The empirical is CH₂. So it's like a recipe as we agreed. What if we got decimals? Let's say I ended up with 1 mole of carbon and 1.5 moles of hydrogen. I can't have half an atom. I cannot have half an atom. So I have to change this into whole numbers. Multiply both of them by 2. So if I multiply this one by 2, it will become 2. If I multiply this one by 1.5, it will become 3. So the ratio is 2 to 3. The empirical formula will be C2H3. Let's try some more examples from our practice book. Find the mass of each element. This is the first step. Convert it into moles by dividing the mass by the molar mass. Then divide by the smallest number of moles to get the ratio of the whole numbers. So, for example, I have copper and oxide. No, it is copper and oxygen inside the copper oxide compound. What is the empirical formula? So you need to find the mass of every one of them. The mass of copper is 2.50. What about the mass of oxygen? I don't know the mass of oxygen. I have the whole compound, 3.13. So to find the oxygen, just subtract the total 3.13 from 2.5. You will get the mass as 0.63. What is the second step? Convert the mass to moles, dividing the mass by the molar mass. So the mass of copper by its molar mass, which is 63.55, of course, from the periodic table, gives me 0.393, and the mass of oxygen divided by its molar mass, 16, give me 0.394. The ratio is very clear that it is 1 to 1. If you want to find it, divide both numbers by the smallest. So 0.393 divided 0.393, you'll get 1, and this one you will get also 1. So the ratio is 0.394 to 0.394. That means 1 to 1. So what is the compound? If the ratio is 1 to 1, so for every copper atom, there is an oxygen atom. The compound will be CuO. I have another compound made from carbon and hydrogen. What is its empirical formula? I have the mass of carbon as 2.4, so I can get its moles by dividing the mass over the molar mass. I will get the moles as 0.20, hydrogen 0.8 over its mass, which is 1.008. I'll get its moles as 0.79. So divide both of them by 0.20. If you divide this one by 0.20, you will get 1 atom for every 0.70 over 0.90 divided by the smallest, I will get 4. So 1 atom of carbon for every 4 atoms of hydrogen. This means that the ratio is CH4. Now using the percentage composition is a similar thing, exactly like the atomic masses, but exactly like the masses, but instead of saying mass, I will say it as percentage composition. So the compound is made from 40.92% carbon, changes into grams. This means that in every 100 grams, there is 40.92 carbons. So the mass is 40.92, for hydrogen is 4.58, for oxygen is 54.5. So just changes the percentage into masses. Again, the first step was to find the number of moles, then divide by the smallest number of moles. The number of moles here by dividing by the molar mass for everyone, divided by 12 for carbon, 1 for hydrogen, and 16 for oxygen. So I get the number of moles, that's 3.407, 4.54, and 3.406. How to find the ratio? We said to divide by the smallest. Smallest is 3.4. So I will get the ratio as 1 to 1.33 to 1. You remember what we said when we get decimal? Multiply it by a number until you get a whole number. The whole number here will be, if you multiply it by 2, this will be 2 and this 2 and this 2.66. So it's not enough. You need to multiply it by 3. When you multiply it by 3, the ratios will be 3 to 3.99, which I can say it is 4 to 1, which is 3. And the correct answer will be 3 to 4 to 3. This means that the ratio is 3 carbons to 4 hydrogens to 3 oxygens, C3H4O3.